In chapter 14, we are going to take a look at all different sorts of measurements, but we're going to start with the most basic one-dimensional measure, linear measure. So linear means line, that's why it is one-dimensional. So you will be able to convert between different measures, and as you'll notice, you have a couple charts on the front of your note packet for lesson 14.1. We're going to take a look at some dimensional analysis, hopefully refresh on perimeter and circumference. Hopefully we've seen those before. And then we're going to take a look at ratios of linear measures of similar figures. Now that's not going to be the big focus on this one. We're going to look more at ratios for area and for volume when we get to those later this chapter. Okay, so just to refresh, a yard is 3 feet, a foot is 12 inches, and a mile is 5,280 feet. Typically, that's the one that people have memorized. They don't have the yard conversion. If you do and you're more comfortable working with that, go ahead. I'm always going to default to the 5,280 just because that's what I have memorized. So no better way than to just bust into an example. So we're going to skip to page 2 of your handout, and I'm going to have us go back to that example, but first I want us to practice with some where all of our measures are the same. So that first example there says convert 5 1/4 miles to yards. So like I said, I'm going to use the feet first conversion because that's what I have memorized. So to set it up, first we do 5 1/4 miles. Now I sometimes write this over 1 as a fraction just because that's what I'm used to. You definitely don't have to do that. If it helps keep you straight, then I encourage you to do it. All right, so then I have to figure out how can I get rid of miles. So thinking of it, the equivalent in feet would be 5,280 feet, and that's 1 mile. Now, how do I know that I put the 5,280 on top? The goal is to get the miles or the label of miles to simplify. So to do that, we have to have miles on top and miles on bottom of this ratio. That way they will, if you wish, cancel each other out. Now again, we're not quite to yards, and the goal is to get to yards, but I know how many feet are in a yard. There are 3 feet in a yard, but again, since feet is on the top of this fraction, my goal is to get feet on the bottom of my fraction. So I would put 3 feet on the bottom, and its equivalent is 1 yard. Now, let me show you how the labels simplify. The miles, like I said, miles over miles, we're basically dividing it out. It would be 1. And then feet and feet again. So our unit that we're left with, if we multiply straight across, 5.25 times 5,280 times 1, all divided by 3, we get 9,240. And then as we can see, our label here is just yards. Okay, maybe the next one, maybe you're comfortable with this or you remember it. Go ahead, pause the video and try this next one. If you need to practice one more together, we'll go ahead and talk through it. So if a cheetah is clocked at 60 miles per hour, what is its speed in feet per second? Now I'm changing both. I'm changing miles to feet and hours to second. So setting it up, 60 miles per hour, I have my label. And again, if you want to think about this as 60 miles per 1 hour, that's totally fine if it helps keep you straight. Then I'm going to multiply it. I chose to convert it to feet first, but you definitely could have switched and gone to seconds first. It doesn't matter. If you remember, multiplication order does not matter. So since the miles was on top, I'm going to put the miles on bottom. The equivalent of 1 mile is 5,280 feet. Now next I need to get rid of hours. Yes, you might know how many seconds there are in an hour. Go for it. I'm going to just show you how I would do this in 2 steps. So to get rid of 1 hour, I put my hour on the top of the fraction. Its equivalent is 60 minutes. Now, I want seconds, so I need to go a bit further. 1 minute. And again, since I'm trying to get the minutes to go away, I put minute on the top. And that is equivalent to 60 seconds. Now we can see our miles reduce, the hours reduce, and the minutes reduce, and we are left with feet per second. You can do this in several different ways. These sorts of conversion problems you can set up with different fractions, different orders, and ultimately, as long as you result in the same answer, that's what we're looking for. So now if I multiply across 60 times 5,280 times 1 divided by 1 times 1 times 60 times 60, we get 88. And then our label is feet per what? Per second, because that is what remains. All right, so we just took a look at some English system conversions. Let's take a look at the metric system. So the metric system is typically easier for students because we're looking at these base 10 values versus trying to memorize, oh, there's 12 inches in a foot, 3 feet in a yard, 5,280. These are just factors of 10. So again, typically it's easier, but I want to show you a couple different ways that you can set up these types of problems. And if you think about them differently than the way I'm showing them, go for it. It does not matter. However your brain works to solve these is totally fine. So maybe sometimes in like science class, your teacher maybe gave you a quote unquote cheat sheet to help you remember the differences between them. That looks like this. And then like if you were going up, you multiply by however many bumps you had, or down. I honestly just want you to think about how many units there are in the equivalency to help us do our conversions for our class. So just some standard measurements to kind of estimate, because that's what we first want our students to do, is to be able to estimate. The length from your shoulder to your fingertip is about 1 meter. Of course, it's not going to be exactly 1 meter for everyone, but that's why it's called a benchmark measurement. The width of your hand is about 1 decimeter. The width of your finger is about 1 centimeter. And again, of course, people have wider fingers, but it's just a benchmark. And then the width of a paperclip is about 1 millimeter. So let's take a look at some examples. Again, several ways to set them up as long as we result in the same thing. I have 1.4 kilometers, and I am trying to convert that to meters. Now, in a kilometer, there are 1,000 meters. So this is the ratio that I'm going to set up. 1.4 kilometers, and like I said, I like to put it over 1. You don't have to. And then the equivalency for meters is 1,000 meters in 1 kilometer. So I need my kilometers to reduce with one another, which is why I put it on the bottom of the second fraction. And then we can see it simplifies, and multiplying straight across, 1.4 times 1,000, we get 1,400 meters. So if you feel pretty good, go ahead, do this at your own pace. For my second one, 285 millimeters, and I'm converting it to meters. So I kind of did this a different way, but if you think about it differently, I'll explain that here in a second, and I'm fine with that. So the equivalency for 1 millimeter, which is kind of atypical to think about it, I think this is backwards, but 1 millimeter is 0.001 meters, or 1,000th of a meter. Now to think about this another way, my second fraction, I could have said 1 meter over 1,000 millimeters, rather than dealing with decimals. But it's totally up to you either way. When we do it, when we multiply and then divide, we would get 285 thousandths, or 0.285 meters. All right, now the last one, I do not know the equivalency from kilometers to centimeters. I could figure it out, but I'm just going to set up my my ratios. So I have 3/100ths of a kilometer. Now I know how many meters are in a kilometer. For me, that one's memorized. So that's why my next fraction, I did the equivalency for 1 kilometer and I changed it to meters. So 1,000 meters. Again, emphasizing kilometers. One goes on top, one goes on bottom, because I'm trying to get them to reduce one another. Now the goal is to get to centimeters. And I know that 1 meter is equivalent to 100 centimeters. And since meters was on the top, I put my label or my meter value on the bottom. Then multiplying straight across, I would get 3,000 centimeters. And again, the only label that is left after reducing is centimeters, and my denominator, they are all 1. So we can just multiply straight across on this one. Again, there are other ways to think about it. So if you figured out another way, go with what makes sense to you. All right, the next concept I want to talk about is perimeter. Perimeter is just the length of a closed curve, or the sum of the lengths of a side of a polygon. I am sure you're familiar with this, and if you want to go ahead and just pause the video and calculate all of these and wait for the answer, that's totally fine. So the perimeter of the first one, the triangle, 3 plus 3 plus 3 would be a total of 9 centimeters. Now the rectangle one, that's not as straightforward because I don't have just quantities that I'm adding up. I have variables. So if I were to add it, it would be W plus L plus W plus L. But I can combine like terms. I would have 2 L's and 2 W's. So that would be my sum. And that's as far as I can go with that one because I don't know what the value of L and W are. Same thing with the bottom one. Yes, we could have S plus S plus S plus S, but that would just be a total of 4S. And then the last one, adding up all of the sides. Now you got to be careful here because notice I have 3 centimeters, 1 centimeter, 3 centimeters. Then I switch to millimeters. So we could look at this 2 different ways. One, we could convert them all to millimeters. So it would be 30 millimeters, 10 millimeters, 30, and then we still have our 40 and our 60. Or we can convert the 40 millimeters and the 60 millimeters to 4 centimeters and 6 centimeters. So my other possible answer would be 17 centimeters instead of it in millimeters. Either way, up to you. Okay, circumference is the perimeter of a circle. It's all the way around the outside, if you will. And the equation for circumference is 2 times pi times r, where r is the radius. Now, that is the typical formula that we use, but sometimes we use circumference is equal to pi times diameter because diameter is literally 2 times the radius. So what they're just doing is combining the 2 and the r into the diameter. That's it. So that's really where that is coming from. But again, like I said, typically we use the 2 pi r. All right, now this one might be new to you. If I don't want the entire circle's perimeter and I just want like this blue region, we call that an arc length. It is part of the circumference and it has to do with the angle that is given here. So what we can do is we can set up a proportion. And how we do this and why this works. I am saying I want some angle out of the whole circle. Well, the central angle is what I'm looking for out of that whole entire circle. A whole circle is 360 degrees. And that is going to be equal to the ratio of the arc length. So again, the corresponding length to the angle over the entire circumference. And this is just the formula for circumference, 2 times pi times r. So that's where that's coming from. We're looking at the ratio of the part to the whole for the angle and the part to the whole for the circumference. Let's take a look at some examples. So if you feel like, okay, I think I can do this, just pause the video, check back in with the answers. But I'm going to explain how to do each one. So the circumference of a circle with a radius 2. I know the formula for circumference is 2 times pi times r. So this would be 2 times pi times 2 because my radius is 2. And that, combining like terms, 2 times 2 is 4 pi. And if I go to decimals, it's about 12.57 meters. So that would be all the way around a circle. Now this one's a little different. I'm asking for the radius of a circle. We know the circumference. Okay, well, circumference is 2 times pi times r. So I'm going to set up an equation. My circumference is equal to, well, I know what it is, 15 pi. I'm going to divide by 2 pi, divide by 2 pi. The pi's would cancel each other out, and 15 divided by 2 is 7.5. Therefore, my radius is 7.5 meters. All right, for this next example, we are going to take a look at the original proportion that I showed you to find arc length. So arc length is the central angle, the part, out of 360, the whole circle. And we're trying to find the arc length over the entire circumference. So we know the central angle in this case is 25 degrees. We also know we have a diameter of 10. Now be careful because it's a diameter of 10, not a radius. And the formula here is 2 times pi times radius. So I can write that radius is 5 because it's half the diameter. So 2 times pi times 5. Or you could just say 10 pi if you wanted to leave it in the diameter formula. Now we are looking for the arc length, so I'm going to put an x. To solve a proportion, which we've done before in class, we multiply the cross products. So 25 times 2 times pi times 5 is equal to 360 times x. So my equation looks like this. Now, I did combine the 2 and 5. That's where that 10 pi is coming from. So it's 25 times 10 pi equals 360 times x. Now, to do a little bit of algebra, to solve for x, we need to get rid of multiplying by 360. So we divide both sides by 360, and we get that x is approximately 2.18 centimeters. So the arc length is just over 2 centimeters for a 25-degree angle. That's a pretty small angle if you think about it. Like not a very big slice of pizza, and our arc length is 2.18 centimeters. Okay, now I want to use that proportion to solve for something a little different. This time we're looking for the radius of an arc, and we know the angle, and we know the arc length this time. So we can go backwards and solve for what the radius is. So set up the proportion. Central angle, I know that, it's 87 degrees. Now I know the arc length is 154, and my whole goal is to solve for the radius. So just like the last time, multiplying cross products so I can set up an equation, I would have 87 times 2 times pi times r equals 360 times 154. Now what I'm going to do is I'm going to combine that 87 times 2 times pi. Go ahead and get my answer. It's about 546.637. It keeps going on. I just chose to round to 3 decimal places. Times r, and then 360 times 154 is that 55,440. Once again, once we have this all set up, it's just algebra. So I need to divide both sides by 546, and I get the radius is approximately 101.4 centimeters. That's a pretty big circle, a radius over 100 centimeters. Now, if you remember our conversions, why not think about this? How many centimeters are there in 1 meter? There are 100. So this is like over a meter. Like that's how big this circle is, just to put that into perspective. All right, and that's a wrap on lesson 14.1. We looked at units of measure for both the English and the metric system, how to do conversions in both, and what it means to be the perimeter or circumference, and then maybe a new term for all of you is the arc length. I have 3 things that I want you to do, and they're pictured here on the screen. I need you to finish examples 10, 11, and 12 in your notes. They're 3 perimeter examples. Now, maybe you're like, what the heck? Those are way harder. That is the point. I want you to make sure that you label all of the missing sides because some of the sides are not marked in those examples. So just be careful with that. Then I need you to complete the first page and a half of notes. So now that you know, or maybe refreshed on how to convert between units of measure, you can go ahead and use those values that we got. You do not need to do number 6 because we did not go from Gildemeister to the library due to the weather, so you can just go ahead and skip number 6. And then the last thing that you need to do is homework 14.1, and that can be found on D2L. Please let me know if you have any questions, send me an email, and I'd be happy to help.